Good morning, friends. So, from today, we are going to start our online lectures. So, welcome you all in part 2. Now, you are in MSc 2 and we are going to start our semester 3. Let's start with the paper 1 with unit 4, and that is photochemistry. See some key points for this lecture. We are going to see about what is mean by photochemistry, then electronic state and transitions in photochemistry, and some selection rules. So, actually, what is mean by photochemistry? Photochemistry is a branch of a chemistry concerned with the chemical effect of light. Means generally we do our reaction in presence of heat, in presence of microwaves, etc. etc. So for any completion of any reaction, we must provide some energy to that reaction. Okay, when this energy, supplied energy, is in form of a light, then that reaction is called photochemical reaction. So photochemistry is a branch of chemistry concerned with the chemical effect of light. Generally, this term is used to describe chemical reaction caused by absorption of light. So molecule will absorb that photons or energy in light and go to excited state, and further product formation takes place. So the light may be in ultraviolet, then it may be in a visible light, or maybe in a infrared radiations. Okay. Nextly, see the introduction of photochemistry. Ordinarily, the energy required for a reaction is provided by heating the reaction mixture. In case of organic chemistry also, and in case of inorganic chemistry also. In case of organic chemistry, just we do reflection or heating in a water bath, heating on a sand bath. In organic chemistry also, we just do digestion of the product. Then when in ordinary reaction we give this energy is in form of heat, when it is possible to provide the same energy by exposing the reaction mixture to light containing a different frequency, which can be absorbed by the reacting molecule, or that for that the presence of chromosphere is essential on the absorbing molecule. So chromosphere, you know already word like chromophore, oxochromes. Okay, so chromosphere, the particular nature or particular arrangement in the molecule that can absorb a light. So the energy that provide in the form of light differ in the energy which is provided as a heat in one important aspect. So the heating raises the energy of all molecule in the reaction mixture, whereas the light energy may be absorbed by some or individual molecules and may not be absorbed by other molecule. See, when we put any reaction mixture in any beaker, in one pot synthesis, let's consider in one pot synthesis, all reacting molecules, all reactant are in one beaker, and we give just energy in form of a heat, then all reacting molecule take that energy in a simply same manner. But when we do photochemical reaction, when we apply some photons or any wavelength of energy in form of a light, then that different reacting molecules will be there. Only that reactant will absorb that light which have perfect chromosphere. So not all molecule will get to the excited state or give reaction. Only that molecule will give you product that which they have chromospheres. Such a reaction which are brought about by light are known as photochemical reaction. So simply the reaction which brought about by or in presence of a light called a photochemical reaction. So let's see the difference between photochemical and thermochemical reaction. The main difference is, first see photochemical reaction. The photochemical reaction that takes place in presence of a light energy, while the thermochemical reaction simply they takes place in presence of a heat energy. In case of photochemical reaction, see the second point, the reactant molecule should preferably have a group called the chromospheres which can absorb UV and visible light. So word chromosphere is important here. Okay, so note side by side in your notebook, the word chromosphere is important. If the molecule contains chromosphere, then and then only the molecule can absorb the light or absorb that energy from the light, from visible light or UV light, and can form a product. Okay, but in case of a thermochemical reaction, presence of chromosphere is not necessary, because we are doing a thermochemical reaction. We are supplying a heat for the reaction. Okay, presence of chromosphere is not necessary in thermochemical reaction. See the third point. Rate of photochemical reaction are independent on temperature of the reaction, but depend upon the intensity of light absorbed. As we are doing photochemical reaction, our reaction rate is depend upon actually upon what much wavelength light we are using for the reaction. Okay, so it is independent upon the temperature. But in case of a thermochemical reaction, as it is a thermochemical reaction, we are supplying heat to the reaction, the rate of thermochemical reaction is depend on the temperature. Okay, we already see about SN1 reaction, SN2 reaction. In that we do study about rate depend upon concentration of reactant, concentration of reactant means concentration of reactant, then what solvent we are using. As also temperature is also important factor in that. Okay, but in case of a photochemical reaction, the reaction depend upon the intensity of light absorbed. Okay, the last point, that is degree of excitation can be controlled by choosing the desired wavelength. The degree of excitation can be controlled by choosing the desired wavelength. So degree of excitation we can see further. So just point out this degree of excitation, as the molecule will absorb light energy and go to excited state. So at that instant, how much molecule or how much electrons will go in excitation. So degree of excitation can be controlled by choosing the desired wavelength. But in case of thermochemical reaction, exact energy of excitation is not known, because exact number of molecules is taking part in the reaction are at the instant cannot be determined in case of thermochemical reaction. Let's see the next point. Actually, what is meant by photochemistry? We say electron will go in excited state. See, first your molecule will be in the ground state, M0. See this M0, some notation you have to note here. M0, when the molecule is in a ground state. H nu is a photon, that is quanta, amount of energy in a discrete patterns present in a light wave. So it is a quanta, and this is molecule in excited state, M star. So excited state molecule. First the molecule in ground state, then as it absorb energy in case in form of a quanta from the photon, it will goes to excited state, that is M star, excited state. So this is electromagnetic radiation induce excitation and relaxation. Excitation means when the molecule takes or absorb photon from the light energy, it will goes to excited state. Are you getting my point? See here the electron in a ground state, as it absorb energy, it will goes to excited state. This is the difference is delta E. Okay. Mechanism of photochemical reaction. A ray of light behaves as a train of discrete energy packets known as photons or quanta. See here, photons or quanta. The energy contained in each photon depends upon the wavelength corresponding to that. Means a photon or a quanta is considered as a small packet of unit of energy in that wave. So wave is considered as a train of such energy packets called photon. You notice that regularly in photochemical reactions they have written H nu on the arrow. So you can easily notice that this reaction will be going through photochemical pathway. The energy contained in such photon, it's depend upon the wavelength that which we are using. Means if wavelength is high, frequency will be low. That is mean by the photon will also have low energy and vice versa. So energy of photon or quanta is depend upon the wavelength of light. And in photochemical reaction, as we are doing our reaction by only this light or photons, the wavelength selection is much more important. So in mechanism of photochemical reaction, wavelength plays major role. So the energy contained in each photon depends upon the wavelength corresponding to that photon, and the energy contained in Avogadro's number, that is 6 into 10 raised to 23 of photon, is known as Einstein. It is equal to 2.86 into 10 raised to 4 per lambda, means per wavelength, kilocalorie per mole, where lambda is wavelength in nanometer. Thus the value of Einstein also depend upon wavelength. Here see, we are calculating the value of Einstein and by using the wavelength. So the value of Einstein also depend upon wavelength. Next is electronic transition and excited states. Is actually meant by electronic transition and excited state when a wavelength is absorbed by from the UV or visible region. Okay, when a wavelength is absorbed from the UV or visible region by any molecule, the energy gained by the molecule is used to shift from the bonding or non-bonding molecular orbital to an anti-bonding molecular orbital. You know, the ground state is bonding molecular orbital, middle one is non-bonding molecular orbital, and higher one is anti-bonding molecular orbital. So when the electron will absorb energy, then firstly may it go to non-bonding energy level, and after that it may go to the anti-bonding energy level. So this shifting of electron may retain its spin. I mean, if it is go to non-bonding or to anti-bonding, it may retain its spin, means its spin remains same, or it may can change its spin. So it is said that the molecule has been raised from ground state, that is S0, to excited state, maybe a singlet state. See, you can see here in this diagram, here is S0 for the singlet state. Okay, so this is ground state, singlet ground state. S1 is a singlet excited state. S2 is also singlet excited state. Here is a T2 triplet state, we will see it afterward. Triplet state, this is T1 is also triplet state. So first the molecule is in ground state. I think we missed one slide. Yeah, just see, here is the ground state and is excited state. First the molecule is in ground state, then it will go in excited state after absorption of the photon, that energy, it will go in excited state. Now this excited state will be a singlet state or a triplet state. Now see, if the molecule is in after excitation remain in the same spin, then it will be a singlet state. If it change its spin, then it will goes to a triplet state. See, S0 is the ground state. When it absorb energy, it will goes to S1 or S2 singlet state, S for singlet, S1 or S2, and maybe in a triplet, T1 or T2. However, if the shifting electron change its spin, the molecule said to be raised from ground S0 to excited T1 triplet state. If it's changed its spin, it will go from S to T singlet to triplet. So see, if spin remains same after excitation, it is a singlet state. If the spin get changed, okay, shifting of electron change its spin, then it goes to excited triplet state. It is found that the molecule is an excited triplet state has lower energy than the corresponding excited singlet state. See, this is notable point. Singlet state has a lower energy, singlet state has higher energy than triplet state. Okay, molecule is an excited triplet state has lower energy. Lower energy means energy low. Lower energy means stability is more. Energy is lower, stability is more. Energy is high, stability is high, means instability. Okay, so molecule is an excited triplet state has lower energy than the corresponding excited singlet state. या ट्रिपलेटच्या आहेत आणि ह्या सिंगलेटच्या आहेत. ट्रिपलेटची एनर्जी सिंगलेटपेक्षा कमी आहे, ट्रिपलेटची एनर्जी सिंगलेटपेक्षा कमी आहे. सो ऑलवेज ट्रिपलेट स्टेट हॅज लोअर एनर्जी दॅन सिंगलेट स्टेट. ओके, सी what is mean by actually singlet state and triplet state. When we see singlet state, a molecule is said to be singlet state if all the electron in it are paired. Singlet means in each molecule, if you say there is a pair of electron, means there is a pair of electron. One will, if they are anti-parallel, then there is a pair of electron. If they are a parallel, then they will show triplet state. See, in a singlet state, a molecule is said to be singlet state if all electrons are paired. It is represented by the symbol S. In case of a triplet state, a molecule is said to be triplet state if two electrons in a molecule have parallel spins, means positive positive. It is represented by the symbol T, triplet for T and singlet S. According to Hund's rule, orbital having higher multiplicity are more stable. Thus, triplet state is more stable than corresponding singlet state. See, what is meant by actual multiplicity? Here, multiplicity of orbital can be calculated by the formula. See, this formula is important. Multiplicity is equal to 2 into sum of spin plus 1. 2 into sum of spin plus 1. In case of a singlet state, let's see, m is equal to 2 into plus half. We see here, in singlet state, there is a pair of electron. Pair means one is plus and another electron will be negative. So plus half and minus half. So 2 into plus half minus half plus 1. Plus half minus half 0. 2 into 0 0. 0 plus 1 1. So m is equal to 1. So multiplicity for singlet state is equal to 1. But in case of triplet state, see here, m is equal to 2 into plus up, because both are parallel. So plus half plus half plus half plus half 1. So 2 into 1, it's 2. 2 plus 1 3. So for a triplet state, multiplicity is 3 and multiplicity is more, means that electron can be in a different three different sets. It can be stabilized itself in a three different forms. So as multiplicity is more, its stability is more. So in case of singlet and triplet, the singlet state has multiplicity 1. The singlet state does not split in magnetic field. The direction of spin of one electron is inverted and reversed. In other case, the electron spin are parallel. In case of triplet state, electron spins are parallel. Thus magnetic moment does not compensate. So the net magnetic moment will be sum of the two. That's why we are doing plus 1 plus 1. Such state is called as a triplet state. They are denoted by T0, T1, T2 and other different energy triplet states. In this case, the multiplicity is given by m is equal to 3. Thus the triplet state is more stable than singlet state. Why? Because in case of triplet state, you can see the electron can be stabilized itself in a three different steps or three different types. Okay, and in case of a singlet state, as there is a magnetic field, the molecule will not split in a magnetic field. So there will be, for the stabilization, there will only one possibility. But in case of triplet state, there are three possibilities. So as spin multiplicity is more, stability is more. So triplet state is more stable than singlet state. Okay, so for next lecture we will see Jablonski diagram. It is one most important problem regularly asked in your exams. So we will see in next lecture. Thank you.